There is a noise that Toyota owners dread more than almost anything else. It starts subtle, maybe a faint whine when you first back out of the driveway on a cold morning. Then over a few weeks, it grows into something that genuinely sounds like your engine is being torn apart from the inside. A high-pitched mechanical screaming that peaks every single time you turn the steering wheel, sometimes accompanied by red fluid bubbling aggressively out of the power steering reservoir cap like something inside is boiling. If you have heard this noise, you already know exactly what I am talking about. And if you have taken your Toyota to a shop with this problem, there is a very good chance you were quoted somewhere between $800 and $1,200 to replace the power steering pump and flush the rack. What most shops will not tell you, and what we are going to walk through in full detail today, is that in a very specific and remarkably common version of this problem, the pump itself is completely fine. The metal vanes inside that pump, the bearings, the rotor, all of it is intact and functioning exactly as it should. The terrifying noise and the bubbling fluid are coming from something else entirely, something so small and so cheap that it almost defies belief. We are talking about a rubber O-ring the size of a coin, available at any auto parts store for roughly $2, located on the outside of the pump where the plastic suction hose connects to the metal pump body. When that O-ring fails, it sets off a chain of fluid dynamics events inside your hydraulic system that produces a noise and a set of symptoms so perfectly identical to a destroyed internal pump that even experienced mechanics get it wrong or choose not to look any further. To understand why a $2 rubber ring can cause all of this, you need to understand how Toyota's traditional hydraulic power steering system actually works, because it is a genuinely elegant piece of engineering that most people have never had explained to them properly. Toyota leaned heavily on hydraulic power steering throughout the late 1990s and into the 2000s and beyond, fitting it to the Camry, the Corolla, the Tacoma, the 4Runner, the Sequoia, and dozens of other models across multiple generations. The system was chosen because it delivers a level of steering feel and road feedback that early electric systems simply could not match. Hydraulic systems respond to actual physical load. When you are parking at low speed, the pump works hard and provides maximum assist. When you are cruising on the highway, the system backs off and the steering tightens up naturally. The physics are direct and mechanical, and Toyota's implementation of these systems was genuinely robust. Many of these pumps have lasted 300,000 miles or more without any internal failure whatsoever. Here is how the system operates. The power steering pump is a vane-style rotary pump driven by a belt from the engine crankshaft. Inside the pump housing, a central rotor spins at engine speed. Mounted on that rotor are a series of flat metal vanes that slide in and out of slots as the rotor turns. As each vane sweeps around the inside of the housing, it creates a sealed chamber between itself and the next vane. On one side of the pump, those chambers expand as the vanes rotate, creating a zone of low pressure, a partial vacuum. On the other side, the chambers compress, generating high pressure. The low pressure side draws hydraulic fluid in from the reservoir through the suction line. The high pressure side pushes that same fluid out through the pressure line and into the steering rack, where it acts against pistons to provide the physical assist you feel when you turn the wheel. The fluid then returns back to the reservoir through the return line, completing the circuit. The critical variable in all of this is the low pressure side, the suction side. For the pump to draw fluid efficiently and operate quietly, it needs to pull that fluid in under an absolute unbroken vacuum. The suction line must be completely sealed, because the pump is not just moving fluid. It is creating a pressure differential, and any leak in the low pressure side of that system does not let fluid out, it lets air in. Air gets drawn in because the pressure inside the suction line is lower than atmospheric pressure outside it. This is the fundamental physics that makes the O-ring failure so destructive to the system's behavior. The suction line on most Toyota applications is a black plastic elbow, sometimes called the suction hose inlet joint or the suction elbow. It connects the rubber suction hose from the reservoir to the metal inlet port on the side of the pump housing. That connection is sealed by a single rubber O-ring that sits in a groove on the plastic elbow and presses against the machined face of the pump inlet when the elbow is bolted in place with a single 10mm bolt. When that O-ring is new, it is pliable, compressible, and creates an airtight seal. But Toyota's hydraulic systems run hot. The pump sits close to the engine block, Heat soaks into the surrounding components, and over years of thermal cycling, rubber degrades. It loses its elasticity, hardens, and shrinks. A seal that once compressed into a perfect gasket becomes a rigid ring that no longer conforms to the machine surfaces around it. Microscopic gaps open up at the joint. The gaps are often invisible to the eye and impossible to detect by feeling around the outside of the connection because no fluid leaks out. Air leaks in. What happens next is a process called cavitation, and it is one of the most destructive and audibly violent phenomena in fluid dynamics. When the pump pulls its stroke on the suction side and encounters those microscopic air intrusions, the air does not mix smoothly with the hydraulic fluid. It gets violently drawn into the rotating vein chambers and then subjected to rapid, extreme pressure changes as the veins sweep around into the high pressure side. Air, unlike fluid, is compressible. When a bubble of air trapped in a vein chamber suddenly hits the high pressure zone, it collapses. Not gradually, instantly. That collapse is called cavitation, and it generates a localized pressure spike that is audible as a sharp mechanical crack. Multiply that by dozens of vein rotations per second across multiple chambers, and you get a continuous, high-pitched grinding or screaming noise that sounds exactly like metal destroying metal inside the pump. It does not sound like a seal. It does not sound like a leak. It sounds like the internal components of your pump are eating themselves alive. The bubbles also contaminate the fluid that gets pushed into the steering rack. Aerated fluid is compressible in a way that pure hydraulic fluid is not, which means the system loses assist efficiency. You feel added resistance in the wheel, especially at low speed and full lock. The fluid in the reservoir gets churned into a frothy, aerated state and can overflow the reservoir cap as the trapped air works its way back through the return circuit. The visual of bubbling red fluid, combined with the mechanical screaming, creates a presentation that looks and sounds like catastrophic internal pump failure because hydraulic cavitation from an air intrusion and mechanical destruction from failed internal components produce nearly identical symptoms at the surface level. The distinction matters enormously because the repair paths are completely different. Replacing the internal pump means replacing the entire pump assembly, bleeding the system, flushing the rack, and paying for hours of labor. Fixing the O-ring means removing one bolt, pulling one hose, and pressing a new $2 seal into place. The diagnostic step that separates these two paths is also straightforward, and any technician willing to take 5 minutes to investigate can perform it. Here is exactly how to do this yourself and what to look for. Before you touch anything, let the engine cool completely. Power steering fluid runs hot, and you do not want to work around a pressurized, hot system. Once the engine is cold, open the hood and locate the power steering pump. On most Toyota four-cylinder applications, it sits on the front left side of the engine, driven by the serpentine or accessory belt. On V6 applications, it is typically mounted higher, still on the front of the engine. The pump is a roughly fist-sized aluminum or cast iron housing with two lines coming off it. The larger, thicker rubber hose at the bottom or side going toward the reservoir is your suction line. Follow that hose to where it terminates at the pump body, and you will find the plastic suction elbow held in by a single bolt. Before you remove anything, place a clean shop rag underneath the pump and along the front of the engine block. When you pull the elbow, a small amount of fluid will drip from the port. Not much, but you want to catch it cleanly. Locate the single 10mm bolt that clamps the plastic elbow to the pump housing. Using a 10mm socket and extension, break that bolt loose and remove it completely. Set it somewhere you will not lose it. Now gently wiggle the plastic elbow backward, away from the pump body. It may feel stuck if the O-ring has bonded itself partially to the metal surface due to heat and age. Work it back and forth gently, applying steady rearward pressure until it releases. Do not yank it. The plastic elbow is not expensive, but you want to reuse it. With the elbow removed, look at the rubber O-ring in the groove on the elbow's nozzle. In a healthy system, this ring should be dark, pliable, and slightly tacky to the touch. If it is the source of your problem, it will look and feel completely different. It will be hard, possibly cracked, significantly shrunken, and may have a flattened or irregular profile. It may have developed a slight set, meaning it no longer springs back to a round cross-section. Some failed O-rings will slide off the nozzle with almost no resistance because they have shrunk enough to lose their grip on the groove. Use a small pick or a wooden toothpick to carefully remove the old ring from the groove. Do not use a metal screwdriver to pry it, because if you nick or scratch the groove itself or the machined sealing surface of the pump inlet port, you will create a new leak path that is much harder to fix. Take the old O-ring to an auto parts store and match it by diameter and cross-section thickness. Standard O-ring kits or a specific replacement available for your Toyota's power steering suction inlet will give you the correct size. The replacement ring should be pliable and spring back immediately when you pinch it. Before installing it, dip it in fresh power steering fluid or ATF, which is what most Toyota hydraulic systems use. The lubrication helps the ring compress evenly and seat without rolling out of position when you press the elbow back onto the pump. Roll the new O-ring into the groove on the plastic elbow nozzle, making sure it sits evenly all the way around without any twisting. Misalignment here will create a new leak, so take a moment to confirm it is seated properly before proceeding. Now press the elbow firmly back onto the pump inlet port. You should feel the O-ring compress as the elbow seats fully against the pump housing face. Reinstall the 10mm bolt and tighten it firmly, but not aggressively. You are sealing a rubber ring, not torquing a cylinder head. Snug and firm is correct. Over-tightening can deform the plastic elbow or crack the pump housing if it is aluminum. With the connection reassembled, you need to bleed the air out of the system before you judge whether the repair worked. Check the fluid level in the reservoir and top it off to the cold fill line if needed. Now start the engine and let it idle. With the wheels still and the engine at idle, slowly turn the steering wheel from full lock on one side to full lock on the other, 3 or 4 times, then return to center. This cycles fresh fluid through the system and helps purge the remaining air bubbles from the pump and rack. You may hear some residual noise for the first few steering cycles. Turn the engine off, check the reservoir level again and top off if necessary, then start it one more time and repeat the lock-to-lock cycle. In most cases, by the second or third purge cycle, the screaming noise will be completely gone and the steering will feel smooth and direct. If noise persists after thorough bleeding, the next step is to inspect the suction hose itself for cracks or soft spots, particularly near the clamps at either end, and to check the return line fittings. These are less common failure points, but the diagnostic logic is the same. Any air intrusion on the low pressure side of the circuit will produce cavitation. The O-ring on the suction elbow is simply the most common and most overlooked entry point because it is external, accessible, cheap to fix, and easy to misread as an internal problem. This repair is worth knowing because it represents something important about how vehicle systems actually age. Rubber components have a finite lifespan, and in high heat environments, they degrade predictably. The power steering suction elbow O-ring on Toyota's hydraulic systems is one of those components, and understanding what it does and what happens when it fails gives you the ability to make an informed decision when a shop hands you a quote. A proper diagnosis should always include confirming that no external air intrusion exists before condemning the internal pump. If a shop cannot explain what steps they took to verify the source of the cavitation, that is worth asking about directly. The information is not secret, the physics are straightforward, and the fix, when this is the actual cause, genuinely costs $2.05. If this breakdown of how the hydraulic system works was useful, the next video goes even deeper into Toyota's rack and pinion steering system, specifically what happens inside the rack when fluid with air contamination has been circulating for too long, and what the early warning signs look like before that becomes a real problem. It is not a story about expensive repairs, it is a story about what the fluid is actually telling you if you know how to read it. That one is worth having the notification on.